What we're going to talk about today is we're going to recognize patterns, and there's actual patterns, and then we'll try to figure out if there's some sort of rule, like a mathematical rule. So the first thing that I want to talk to you guys about is here we have like a box, right? So here we have one box, and then in pattern number 2 we have 3 boxes, and then in pattern number 3 we have 1, 2, 3, 4, 5, 6 boxes. Okay? And so if you look at that, what are we doing to get from 1 to 2?
Add 2.
We're adding 2. And to get from 3 to 6,
add 3.
Add in 3. Another way to look at that is maybe we're multiplying by 3, right? 1 times 3 is 3. Oh, no, wait, that doesn't work. 3 times 3 is not 6.
They're all multiple.
So what if you were to guess, what do you think we're adding? What do you think the next one? I mean, we see the image, but what do you think we would do mathematically?
Add the next number. And
you add 1 each time.
So what do we add to 6?
4.
4? Okay. So this should be 10, right? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So that's 10. And then, so we added 4. So what should the next one be?
Add 5.
Add 5, which would be?
15.
15. What should the next one be?
Add 6.
Add 6. What should the?
21.
21. All right. Yeah, 21.
I remember when that meme died in like 2014.
Yeah. We're recording. So now we got to do this on our own. Okay? So here I have 2 fish. And here I have 4 fish. And then I have 1, 2, 3, 4, 5, 6 fish.
Add 2 every time.
So I think we do add 2 every time. So the next one should be what number?
8.
8. So I would say 1, 2, 3, 4, 5, 6, 7, 8. Now clearly my fish don't look like the fish on the drawing, but you guys get the gist of it, right? By the way, whatever I write on the board, you guys should be writing down as well. Okay? Now, for problem number 3, or example number 3, we're going to do more of the same. First, let's focus on the visual pattern, and then we'll see what the mathematics behind it is. Okay? So I think the next pattern, because here I have 1 shaded row. On the next one I have, and this is what I'm talking about right here. I have 1 shaded row. On the next one I have 2 shaded rows, and then on the next one I have 3 shaded rows, and then I have like just 1 single cylinder that or 1 column that goes through those rows. So I have 1, 2, 3 shaded rows, so I think I would probably have 4. Very good, thank you. Yep, 4 shaded rows, and then 1 column that goes through like that. And that would be shaded a little bit, right? So now, let's look for the number pattern, okay? So in the first couple of them, I was really focusing on the mathematical pattern, but now we're going to focus on like the visual pattern, right? So, on this one, I have 1, 2, 3, 4, 5 boxes total. On this one, I have 1, 2, 3, 4, 5, 6, 7, 8 boxes total. On this one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes total. Now, if you look at that, what are we doing mathematically?
Adding 3.
We're adding 3 every time. So what do you think we should have on this next box? What's that? 14 boxes total, correct? So it should be 11 plus 3, which is equal to 14. I'm going to change the color here just so we can see. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Did I count that right? Let me count that again. I have 1, 2, 3, 4, 5, 6. Oh, you know what? I counted one too many rows. Let's define how many rows we have. When I shaded it in, it looked a little funny. I counted something twice. Let's count again. That's okay. We're entitled to make mistakes. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, good. It is 14. All right? Does that make sense?
Mm-hmm.
Okay. So now let's move on to the next slide. Now this one, I'm not going to draw the apples because, well, it's not that easy to draw the apples. Well, let's finish this up here. We'll come back to the apples in a second. So now if you look at this pattern, what do you guys think? What do you guys want to do? Do you want to do the math or do you want to do the visual shape?
Visual shape.
Visual shape's probably easier, right? So we start off with one box, then what do we do to get from pattern 1 to pattern 2?
Add 2.
We added 2 on the corners of that box, right? And then from so here I'm just going to write down kind of what we did. Let's just say we put, oops, let me get a color that you guys can see. We put boxes on corners. All right, and technically it's on the bottom. So if we go to this corner and this corner of this box, we put 2 boxes there. Then what do we do if we go from pattern 2 to pattern 3? Yeah, we put 2 on the top, right? But it was on the corners again. And what do we do for pattern 4? Put 2 more on the bottom. So what do you think we would do for pattern 5? Put 2 on top. So for pattern 5, we should have our 1 in the middle. And I'm going to draw it in the sequence so we can kind of get an idea. So what I did is I put 2 on the bottom. And then in the next pattern, I put 2 on the top. Then the next pattern, I put 2 on the bottom. And you guys are suggesting that we put 2 more on the top. Right? Now, I'm sure yours won't be as perfectly drawn as mine. But not only am I a math teacher, I'm also an artist.
A geometry teacher.
Yeah, I'm a geometry teacher, yeah. So you should have a pattern similar to that. And by the way, that's the correct answer. Now, just out of curiosity, what might we do? Whoops, don't like that one. What might we do for pattern 6?
2 on the bottom.
Yeah, so we put 2 on the top, so we put 2 more on the bottom. I'm going to cheat a little bit because, well, that's a lot of stuff to draw by hand. So I'm going to copy and paste on mine. I don't expect you guys to draw this whole thing out. But I will put 2 more on the bottom, right? So I come in here and I go right on the corners. And that would be pattern number 6, right? Does that seem right to you guys? Okay? Cool. Now the apple one, what would pattern number 4 do? You just tell me. We don't have to draw it out.
Add 5.
Add 5 like up in this corner, right?
Yeah.
Pattern number 4, we would add 5 more apples. So from here we're adding 5, right? So this is the original, and then we add 5 more apples. And then from there we add 5 here. And the most likely thing that we would do would be to add 5 right here. Mathematically, though, we would have 5 and then 10. Originally, we had 15 here, and so how many would you have in pattern number 4? 20, right? So you'd have 20 total.
Whoops. Too much.
My smartboard isn't so smart. I got a little excited and drew too fast. My computer couldn't keep up. Okay? All right. So now for pattern number 3, again, what we're going to do, and this time I want to expand just a little bit. Let's look at the visual first, and then we'll come back and look at the math, and maybe there's another way that we could write this out. So I want you guys to take about 10 seconds and just talk to your neighbor.
Hello there, friend.
No, not like that. Talk about what you think you're supposed to do. So take 10 seconds and talk to your neighbor about what pattern number 4 should look like. Ready, go. You probably don't even need 10 seconds, just a couple seconds. Okay, does somebody want to tell me what we should do? Yes.
Add 4.
Okay, add 4. So pattern, what do you mean by add 4? Be a little more specific.
In the bottom right corner.
In the bottom right corner, we should add 4 more.
Yeah.
So I should have, the original pattern was 1, 2, 3, 4, right? That's pattern number 1. Then pattern number 2, we drew 1, 2, 3, 4 more. Then in pattern number 3, we drew 1, 2, 3, 4 more. And you're suggesting that we draw 1, 2, 3, 4. Is that correct?
Yes.
So now we have 4. I got a little too excited when I... So we have 4. Then when we add 4, we get 8. Then when we add another 4, we get 12. And then when we add another 4, we get 16. Correct? Let's look at that for just a second. Okay? Let's look at that for just a second. If I have 4, 8, 12, based on that pattern, and the next one is 16, what's the next number going to be? 20. Where are we getting these numbers from? Right, so write this somewhere on your worksheet, because this is important. Whatever I write down, I want you guys to write down. Well, which term is this, though? Which term is this? So here's what let me show you what I'm talking about. If I take this and just kind of scroll it down here, whoops, I got to do this here. Right? This is technically this is the first term. This is the second term, third, fourth, fifth. So this is the second term. This is the third term. This is the fourth term. And this is the fifth term. Well, hold on. Yeah, you're getting the hang of it. So now we know to get from here to here that we are adding 4. To get from here to here, we're adding 4. Here, adding 4. Here, adding 4. And from here to here, we would add 4. But how do we get from 1 to 4?
Add 3.
We multiply 1 by
4.
4. How do we get from 2 to 8?
2 times 4.
2 times 4, which is 8. How do we get from 3 to 12? Times 4. So there's lots of ways that we could represent this pattern. Probably one way to think of that is if I let this represent any number n, and I let this column represent like a function of n, what would that function be? What's that pattern?
4.
2, or not 2, 4 what?
4n.
4n, right? I don't know why I put 2. So that would be 4n. Now what that means is, if I say the function of 1 is equal to 4 times 1. Okay, write this down somewhere, make room on your paper. If I say the function of 1 is equal, what I'm really saying is, when I plug 1 in, I'm going to get 4 times 1, which gives me 4. That means that there is a relationship between the pattern number of 1 and the number of circles that I have. Okay? Now, if I were to do that again, and I were to write, let's choose a different color. If I were to look at pattern number 2, how would I determine the number of circles? 4 times what number? 2. And that means I would have 8 circles total, right? Does that make sense? Okay, good. So we can determine, you guys have this written down? Yeah. Let's move on to the next one. So now we've got a little more complicated design. The first one is done for you. For question number 7, it says, how many white tiles will be in the design, design 5 of the pattern? Explain your reasoning. So we're only looking for the white tiles. So this is a little more complicated problem because we got to figure out the pattern of the white and the shaded tiles. And then we also have to figure out, like, how many tiles would be white. So let's look at the visual first. Okay? So I have 6 tiles that are there. So I have like 1 shaded and 5 tiles, right?
Yeah.
For design number 1. So I have 1, 2, 3, 4, 5, 6. Now what are they doing from design number 1 to design number 2?
Adding 4 more.
Adding 4 more, but they're spacing, they're putting 1.
They're shading one.
Yeah, they're shading every other one, right? So now for pattern number 4, so for let's just focus on the white tiles. Okay, so we figured out what the visual is, but let's see if there's some sort of mathematical relationship, okay? How many white tiles do we have on this one?
5.
Design number 1 has 5. How many do we have on design number 2? 1, 2, 3, 4, 5, 6, 7, 8. Now how many on design number 3? 4, 5, 6, 7, 8, 9, 10, 11. What is the mathematical rule or pattern that we have there?
Add 3.
We're going to add 3. So the next one should be, in other words, if I were to rewrite this, I would say 5, 8, 11. Next number is
14.
14. Next number is
17.
17. Okay, there will be 17 tiles in design number 5 of the pattern. For every new design, there are 3 more white tiles. Right? Does that make sense? All right, cool. I'm going to let you guys do number 8 on your own, so we'll skip that one. That's a very similar problem. I think we're done. Let me just check one more thing. Let's skip ahead, though. I want to do problem number 12 with you guys. So we'll skip ahead till we get to 12. Let's look at problem number 12. It says, Archie is playing an online game with friends. Each round of the game, he earns 4 times his current point total. The first 3 rounds are shown in the table. How many points does Archie have in round 6? So let's fill this in. We've got round 4, 5, 6. What's the pattern from here to here?
Times 4.
Times 4 could be.
No, it's not. It's
Yeah,
not.
because if you look at the next one, 2 times something equals 4.
Oh, I was thinking like 1, 4, 6.
So that one is not as easy as we think.
Just 1 and 2. 2. And the next one.
Yeah, so they say that it's 4 times each one. So when they say 4 times, they're talking about going from here to here. In other words, oops. if you go from here to here, well, it doesn't like that. It's getting tired of doing this. If you go from here to here, you multiply by 4.
You can draw faster than the computer can process things.
So from 4 to 16, you're multiplying by 4 because 4 times 4 is 16, right? So how do I get this next number? Multiply what by 4?
16.
16. So 16 times, I'm going to write this out. 16 times 4
Oh.
equals 64. So that's our answer, right? Okay. So then what do we do for the next value? Times what by 4?
Times 64 by 4.
64 times 4. So we would say 64 times 4. What would that be? That would be 256, right? And you say, Mr. Adams, how do you know that? Well, if I take 64 and multiply it by 4, Mr. Adams has kind of memorized these. But if I take 64 and multiply it by 4, what's 4 times 4?
16.
16. Carry the 1. What's 4 times 6?
240.
24 plus 1 is
250.
25. So we got 256. So now what do I got to do next?
256 times 4.
256 times 4. So in the next one, I'm going to say 256 times 4. Whew, that looks kind of hard. Let's try it again. You ready? It might be, but let's double check. I want you guys to practice multiplying. What's 6 times 4?
24.
Carry the 2. What's 4 times 5? Plus 2 is? What do I carry? 2. All right. What's 4 times 2?
8.
Plus 2 is 10.
1024.
Good job. Proud of you guys. All right. So you see how that works? What do you think the rule would be there?
You put 5.
Oh, I meant to put 4. Good catch. So this one would be 256. This one would be 64. And this one would be 1024. Good catch. Okay? And that's pretty much it. Are there any questions?
No, sir.